and then you'll just check your work, because the next page is still review, but I'm betting that people are a little dodgy on factoring. Mm-hmm. Are we done? No problem, no rush. righty. You should be done. Okay. Why did I go out of my way to highlight GHIJ?
Because they're all pretty much the same thing.
They're all pretty much the same thing. You'll notice that only the signs have changed. Oh, yeah, it should be. Thanks. Thanks, Ashton. All right, so everyone's good, yeah? Everybody can multiply, yeah? Right? Now, as you just noticed, as Ashton pointed out, if you rush, you might do something dumb, like I did, right? But you will notice that in everyone, something's going on, yeah? We can all multiply still? All right, turn the page over. Let's review factoring. Factoring is the reverse of expansion. So, if it is the reverse of expansion, that must mean division is involved. There's 3 types that we do all the time. First one is greatest common factor. This is an important one because this one should always be done if possible and whenever possible. So it might not be possible at the beginning of a question, but when you get yourself working through it, you may find you could do it later on. Always be doing this every chance you get because it's the number one way. It is the number one way to simplify an expression because it's quick and it's easy to do. All right? All of you have been in my grade 10 class before, already have heard this. All of you who haven't know how to do this anyway. It is very simple. You start with a polynomial. All right? So I'm going to write that polynomial out. AX plus AY plus AZ, and so on. Yes? So, the first thing you do, step 1, you decide on the GCF. The GCF includes both coefficients and variables. So, what is the GCF here? A. So, in this first one, it is A. Then, step 2, divide all by the GCF. So I'm going to divide that by A, divide that by A, divide that by A. When do I stop? When I run out of terms. And step 3, I write the answer. The answer looks like this. GCF bracket, then quotient 1 plus or minus quotient 2 plus or minus till I'm done. So the answer here would be A, X plus Y plus Z until I'm done. All of you already remember this. Most of you see GCF in your heads right away, but then you forget to write it down, which is okay, kind of, when they're as easy as this first one and the second one. But when we get later on, you can't forget the GCF. So let's start with this one. What is the GCF? Step 1, it's 3. Step 2 looks like this. 6x plus 3 over 3 over 3. Step 3, GCF first, 3, then all the answers. 2x plus 1. Not even asking you to tell me the answer because it's so elementary that you're all good with it. Yes? All right. Second one, no problem. Same thing. Decide on the GCF. What is it? 2x. Step 2, 4x squared over 2x plus 6x over 2x. Step 3, 2x bracket 2x plus 3. Yeah? Ease, bees, lemon squeezy, right? That much white space. Does it stay that easy? Of course not. I'm going to give you a third one. I want you to do that one by yourself because you haven't done one by yourself yet. You guys do C. Go. Yes. But it does look a little like a fish. But it is an X. This is an X. X to the power of 2. Let's tidy that up because that's the second question about it. X squared. Z squared. And let's add a Q there just for fun. Because I'm a dink. We've met. You know that already. It's your second year here. Boy, everybody says I'm loud, but I can hear every word Mr. Easton's saying. You're all going to go to each station and roll the dice. I find myself wondering what he's teaching. I bet it's genetics. Now I want to know. I'm going to do a subtle walk by. See if I can figure it out. Denise, you're in charge. Balancing chemical equations. Damn. But he's using the right words, anion and cation. It's awesome. I hate the cations or the negative one. No, cations are the positive one, and that makes me happy because I'm a cat person. So what's the GCF? This one's a little bit weird. What is the GCF? So 7x, y, z. Why is it x, y, z? I can quite plainly see I have two x's there. But I don't have them in the next term. Same with y. I only got one y there, and I only got one z there. So it has to be 7x, y, z. Yes? So I divide it all out, then I write the answer. I'm getting to that. Don't give me away. So you divide all that out, you get the following answer. I'm going to write it in light blue for a reason. 7xyz bracket negative 2 what? X. Then what? Minus 3 what? Z squared. Then plus 5 X, Y, Z, Q. Right? Now, Gervier says, shouldn't I have brought out a negative 7? Well, how can negative be the greatest common factor? Does everybody understand? Here is why. We don't like that. Now, you could argue that if you move the 5 to the front, you'd start with a positive 5. That's cool. You could do that, right? And then what I'm about to say isn't important. Then you could leave it as a 7, okay? But if I changed this to negative instead of positive, now I don't want a GCF because I want to get that negative out of there as well. So I would actually bring out negative 7. Even though negative 7 is not the greatest common factor, we want that negative out of there as well. Is everybody cool with that? So if I change this very first one to negative 6 minus 3, what would this be? Negative. And what would this be? Or this would be the same. Is everybody good? Right? It's just something to remember that we can always take out negative 1 to change what we're dealing with. Everybody okay? All right. Moving on to the second one. Everybody remember how to do these? No? Okay, let's remind you of something. Does everybody remember this handy little shortcut? X squared plus 3 plus 2x plus 3 times 2. Does everybody remember that? Okay, so if I asked you to expand this, you would go x squared plus 2x plus 3x plus 6, right? And x squared plus 5x plus 6. And then you would see 5, 2 plus 3 got me 5. There's my 3 and my 2. They're both positive. 6, 2 times 3 got me 6. That's the little shortcut when there's no number out in front. Do we remember this now? Yes. So what this means when we are working backwards is I need a number that will multiply to 7 and add to negative 8. The way to remember it, if it looks like this, x squared plus ax plus c, you need numbers that add to a and multiply to c, right? So what are they? What are the numbers that multiply to 7? There's only one choice. It's got to be 1 and 7. And somehow I have to make 1 and 7 add to negative 8 and multiply to positive 7. So they both must be negative, right? So it is x minus 1, x minus 7. Yes? But obviously we need some reminders of this. So x squared plus 6x plus 8. Do that one. And what is it? X plus 2, x plus 4. Great. Now do this one. X squared minus 12x xy, and then plus 32y squared. Do that one. I added something there to make it slightly more tricky, but if you knew what to do in blue, make the gold one look like the blue one, do the work, and then add in what was missing. If you're in trouble here. Some of you may be. If you don't know what to do at all, go back to basics. I need to multiply to what and add to what? And I will wait a moment for everybody to attempt it. So it has to be 32 and 12, yeah? Is it going to be 1 and 32? Will that make 12? Is it going to be 2 and 16? Is it going to be 4 and 8? How? And they both got to be negative, right? So it's going to be x minus 4 and x minus 8. Why is this space here? Because I need that y to make the y squared. Is everybody good? Everybody remembers how to do these ones, the easy ones? Yeah? Even when I throw another letter in there, we're all cool? Going once? So we better do another practice because I see a few shaky heads. Again, if you are out of space, don't write it down. Or if you just want to think about it, think about it. Q squared plus 17q minus 60. What do I need to multiply to? Negative 60. What do I need to add to? 17. Is it 1 and 60? Is it 2 and 30? Is it 3 and 20? Of course it is. Because 20 minus 3 is 17. Hey, Mr. DeVries.
Oh, so hard to factor. Who's that?
Oh, that was just something I was showing them.
Oh, okay.
Sorry,
like
man.
a signature.
No. We were talking about changing the hypotenuse to another letter.
Oh, yeah.
And how
That blows their minds.
blows their minds because they aren't confident.
Exactly. Especially if you make a leg C.
Yes,
Yeah.
yes. We know it's this, yes? So it is Q minus 3 and Q plus 20. Yeah? Is this the exact same thing? Okay. Is this no? Why not? When I do this double distribution, I would end up with negative 17, right? Are we all cool? All right. I'm going to slide back over to here. What is weird about the second example? It has a coefficient, which we don't like. We all know how to deal with it, but let's pretend we don't remember. I don't know what to do when there's a 3 there, so I should try to get rid of it. How could I get rid of that 3? Well, I could divide by 3, but then it would have to do it to everything. Does that work? Yes. So this is a GCF question first. So I write 3x squared plus what? 6x minus what? 8. And now, here's the mistake a lot of you will make because you aren't thinking about what you are being asked to do, right? This question says I want to factor it, yes? So that means I need every single factor in my final answer. Is that a factor? Yes or no? It's out, so that's what makes it a factor, because this is 3 times this, right? So I need that 3 in math class. What if I were doing a physics equation? Is my goal to find x? Yes. So do I need that 3? Probably not. You have to know the situation you are in. Is everybody cool? And I'm going to show you what I mean. I'm going to keep referring back to this throughout the next couple of units, okay? But we need to remember that. This is a factor. We need it. But when we're trying to sort out an answer, maybe we don't. Okay? What?
I was going to say, so are we just going to factor this part and then bring it back in after? Not factor.
Well, we're going to see if there's any more we can do. So we've done the first bit. Now I have a new trinomial that looks like it might be factorable. So let's check. I got to multiply to what? -8 and add to what? 6. Can I do it? Is it 1 and 8? No. Is it 2 and 4? Some of you are going to say, yes, it is, because 2 and 4 will make 6, yes? But I need positive 6, don't I? How will 2 and 4 multiply to make -8? One of these would have to be negative, correct? So it would have to be that, -2 and 4, or 2 and -4, correct? So is this done? This is done right now, yes? Because this move will not work. I have to know when I'm finished. However, I want you to rewrite this like up here so it will do the next step. So we're keeping the 3, we're keeping the x squared, we're keeping the -8. What's got to be in the middle there for this to work? And then, Jacob, we're going to bring that 3 back in to take us back to an original trinomial that would have done both factors. Go. If you don't get what I just said, just wait. But if you think you understand what I mean, try it. And I know I probably won't get a lot of response, but would anybody like to tell me something they wrote there? Positive 2x. Does that work? 4 minus 2. That works. So then how would I rewrite this so we were able to do both steps? What would my new trinomial be? Plus 6x minus 24. That would work. What else could I have put there? 3x squared minus 2x minus 8, which would have given me 3x squared minus 6x minus 24. Is everybody good with the basic 2? Almost nobody has trouble with factoring GCFs and these guys. If you are having trouble with it, that's okay. I'm not trying to put you down by saying almost nobody has trouble with it. You just need a little more practice. Everybody sees how it works, right? Okay. This is another easy one, but it seems easy, but it messes with your heads. That says difference of squares, yes? Right? Okay. What's a square? Don't say a four-sided figure with 4 sides all the same with 90-degree angles. What is a square in math? A number multiplied by itself. How do I use math to show any number of which I may be speaking? What's the symbol we use in math for any number in the universe? X. How do I make x a squared? I put a little square by it. What math is difference? Subtraction. Minus difference of squares. So what do I need here? I need it can't be x squared because x squared minus x squared is 0. Y squared. If I have this, I am doing difference of squares. Okay? Any form of this. So let me ask you, Is 16 minus y squared a difference of squares? Yes or no? Yes, it is. Why? Because 16 is 4 squared, right? Is this 4x squared minus 25? Is that okay? Why? Because that's got a square root and that's got a square root. Everybody good? Okay, what about this one? Look closer.
You can factor it by GCF.
I bring out a 3, and then what do I have? X squared minus 9, which is another different squares. Everybody cool? All right, now, this is very easy to factor. It is always the square root of whatever that is plus the square root of whatever y is. That's it. And then we write it again. But we have to subtract. Why do we have to subtract? Conjugate. We want the middle term to drop out. Because this is really x squared minus 0xy minus y squared, isn't it? So really, I need numbers that would multiply to y squared and add to 0, which is obviously plus and minus the square root of y squared. Everybody cool? Now, a lot of people right now are like, they look at that and they're like, because it's all the letters. You're like, oh, barf, gross. But then as soon as you see a couple of examples, it's easy. X squared minus 4. Run it through here. What's the square root of x squared? X. Plus, what's the square root of y? 2. X minus 2. Now check it. X times x is x squared. X times negative 2 is negative 2x. 2 times x is positive 2x. What's going to happen right there? They're going to cancel each other out, and then 2 times negative 2 is negative 4. Is everybody good? All right. What about x squared minus 4y squared? Now what is it? X
Plus
2y, and then x minus 2y. Okay, what about this one? 16x squared minus 25y squared.
It'll be 4x plus 5y, and then just the rest on the side.
Lovely. All right, what about x to the 4th minus 16?
It would be x squared plus 4, and then x squared minus 4. But then you can simplify that further.
Why can I go further with that one?
Because they both still have squares.
Can I do anything further with the green one
No.
or the pink one? The pink one. Can I forget about the green one? No, it is x squared plus 4, and then x plus 2, x minus 2. Are we all good still? We're still good? Okay. X plus 3 squared minus 9. No, wait. Let's go minus 16. Because I realized I did something stupid there. So close. X plus 3 plus 4. X plus 3 minus 4. What is 3 plus 4? He waited patiently. What is 3 minus 4? He waited patiently. Aight? Is everybody good with differences of squares? Okay, the only one I didn't remind you of was this one, but we talked about that one. Orally, we would take out a 3, we'd get x squared minus 9, then we get 3x plus 3, x minus 3. Are we all good? Everyone is good to there? All right, now we get to the one that actually causes problems. And for some strange reason, I just learned, remember how last year I said I knew 3 ways to do these? I just learned a 4th way to do them. I show all 4 ways, and kids still, I don't know. 3x squared, 8x plus 5. What bothers you there? There's no GCF and there's a number out in front. Okay? There are 4 ways that I know how to do this. All right? I'm going to try showing you all of them. All right? You decide the one that works for you, because a great many of you were in different grade 10 class. A great many of you learned different ways. The first way that almost everybody learns, even though I think it's the worst way now, but it's very helpful later on. The first way is called decomposition. Okay? Now, if there was no 3 here, we could do this easily, yes? Right? But there is a 3 there. So this, if it was a 1, we'd be okay. But since it's a 3, we know that we have multiplied by 3 to get that 3, haven't we? Which means we can't be looking at things that multiply to 5. We have to be looking at things that multiply to 5 times 3, which is 15. Everybody cool? So, I'm going to write this out this way so I can refer to the letters. All right? In decomposition, step 1 is you do A times C to get, AC. So in this case, what will that be? 3 times 5 to get 15. That is step 1. Step 2, just like the last one, you need 2 numbers that multiply to A times C and still add to B. So, what are the numbers that multiply to 15 and add to 8? 5 and 3. I did this on purpose because you would see it right away. Step 3, rewrite as ax squared plus factor 1 plus factor 2 plus c. What do I mean by that? 3x squared plus, what was our first factor? 3x. Plus, what was our second factor? 5x. Plus, what was c? 5. Everybody cool? Step 4 is group into 2 binomials. So 3x squared plus 3x plus 5x plus 5. And step 5, GCF till done. So, what is the GCF in the green factor? 3x. 3x comes out and it leaves in there x plus 1, yes? What is the GCF in the pink factor? Plus 5, and that leaves in there x plus 1. Now, is that a factor? Is that a factor? Are they both common? So I GCF again, x plus 1, 3x plus 5. Because there is the common factor, and there are the answers. This is what I was taught. This is what a great many grade 10 teachers are still teaching. I don't really like it, but there it is. That will work for all of you. Everybody cool? The second way. This has a name. I found out the name. And I don't like it. It's a dumb name. But it's called slide and divide. And this is the way I like to do these. Starts the same way. 1, A times C to get AC. So we know that's 3 times 5 to get 15. Step 2, same thing. You need those two numbers. And we know that it's 3 and 5. Step 3, we rewrite as x plus 3, and we leave a space, and x plus 5, and we leave a space. Now comes the division. Originally, we multiplied by 3, yes? The only reason we knew it was 3 and 5 was because we did times 3 at the beginning, right? Have I done any division yet? So now, because 3 and 5 only exist because we multiplied by 3, we then divide by 3. Step 4, simplify fractions. So that's going to be x plus 1, right? And x plus 5 over 3, because that doesn't simplify. And step 5, slide any denominators to the coefficient spot. So, x plus 1, no denominator. There's the denominator. It slides to the front, 3x plus 5. And you see, we ended up with the same answer. Everybody cool? Everybody cool? The third way. And I don't know what this one's called. Guess how it starts? Same way. This is just this new way I learned. Step 1 is still A times C equals AC, so it's still 3 times 5 equals 15. Step 2, still the same. Same. Decide on your two numbers. Okay, so it's still 3 and 5. Now here's where it gets weird. In this way, you don't make it x, you use 3x and 3x plus 3 plus 5. You keep the first coefficient, and step 4, you GCF if you can. Where is there a GCF there? That one could take out a 3, right? So I get x plus 1. Any GCFs there? So I leave it as 3x plus 5. And then I get the same answer again. You can either go x and x and use fractions, or you can go with what you have and then factor out. No, there's no 3 out there. That's where it gets weird. It's technically not GCF. That's why I'm okay with this one, because it doesn't put any fractions in there, because most of you are scared of fractions. Now, I said there's 4 ways. You can write these down if you want. I don't care. I don't like these two because these last 2 ways involve guessing. Was there any amount of guessing here on any of them? Did we ever go, I wonder if? Not once. There is another way, 3x squared plus, what was it? 3x squared plus 8x plus 5. 8x plus 5. There's another way to do these, and it's simply this. You factor the first one. It can only be 3 and 1, right? You factor the second one. It can only be 5 and 1, right? So you know that it's going to be 3 and 1 on one side and 5 and 1 on the other side. And then you just start basically guessing. If I do 3 times 1, what do I get? 3. If I do 5 times 1, what do I get? 5. 3 times 1 is 3. 5 times 1 is 5. 3 plus 5 is 8, right? So once I have everything right, all I do is I look straight across. 3x plus 5 and 1x plus 1. And it's real easy when the numbers are small and your only option is 3 and 1. Everybody with me? But what happens if I gave you 12x squared plus, let's go with, no, I don't want it to be that way. 10 plus 43x. Now that, what are my options for 12? 1 and 12, 6 and 2, 4 and 3. 10, 5 and 2. Now I got a whole bunch of weird stuff to put here, right? And it can be made even more difficult by making something a negative. That's why I don't like this one. But a lot of people like it. You're welcome to use it. The way to do it is to think what could be a pair of factors for A and C. And then you got to start guessing. All right? Everybody with me? Now, let me show you what I mean if it's a problem, or that what makes it a little more difficult. Let's say that is -5, right? Okay, so now we've got 3 and 1 and 5 and 1 still, yes? So I still got 3 and 1, I still got 5 and 1, but one of them has to be negative, right? Everybody with me? So if I put the negative there and I check, 3 times 1 is 3, right? 5 times 1 is -5, right? Is 3 minus 5 positive 2? No, so it can't be a -5, can it? So then I got to erase all my work. Okay, maybe it's this. 3 times 1 is -3. 5 times 1 is 5. Is -3 plus 5 positive 2? So now I have it. Then I would go straight across. 3x plus 5 and x minus 1. Everybody cool? Everybody good? I don't like this way because when the numbers get big, you're guessing. And why would you guess if you don't have to? Right? Everybody good? So you choose your method that works. They've all been recorded. I didn't have room to write all four because I made the first one too big. That's my fault, not yours. The only other thing I want to talk about is something like this, and it won't take much room. You already saw it once today. X plus 2 squared plus 7 x plus 2 plus 12. Is this any different than m squared plus 7m plus 12? No. So you factor this, and then you put those, I shouldn't have used green, in for your m's later. Everybody good? All right. We are still technically on review. You do 57 and 58 and 59. Rest of class, I want to see it done tomorrow. All right? And you'll see why in 2 days, why I need you this good at factoring. Okay? Go. Test will be Wednesday, I mean. Yeah, all this will be ready for Wednesday. Yeah, go to the washroom.